Assalamualaikum and hi everyone. Let's continue our lesson on lecture 3 of 4. Learning outcomes. Okay, for this lecture is to solve problems in social science and management.
Okay, first we must describe what is X, and for this question we can describe X as the mark of the biology test. A normally distribute with mean 60 and a standard deviation of 6, so mean or mu equal to 60 and standard deviation equal to 6. X has a normal distribution with mean 60 and standard deviation is 6. If the passing mark is 38, find the probability that a student randomly selected did not pass the test. So we can write as Px less than 38 and draw a picture for this question. This is a X distribution with mean 60 and standard deviation 6, and we can draw 38 and sketch the area that X less than 38, and then we change to standard normal distribution. Okay, Z less than 38 minus 60 over 6, we get Pz less than negative 3.67. Okay, we draw Z distribution with mean 0 and 38 become negative 3.67, and because we use Pz greater than or equal to Z to get the answer, so we must change our graph to the right side with mean 0 and negative 3.67 become 3.67 because the area Px less than negative 3.67 is the same with area Pz greater than 3.67. Okay. From this statistic table, look at 3.6 in first column and 0.07 the other top, and the corresponding area is 0.0012. So the answer Pz greater than 3.67 is 0.0012. Okay, B, find the probability of the student get less than 65 mark. So we can write Px less than 65, and we sketch X distribution with mean 60 and line 65, and we sketch the area Px less than 65. Okay, we change to standard normal distribution. We get Pz less than 65 minus 60 over 6, and the answer is Pz less than 0.83. And then we draw Z distribution with mean 0 and 65 becomes 0.83. Okay, because we use positive Z table, cannot read Pz less than 0.83, so we must change to 1 minus Pz greater than 0.83, and we read from statistic table. We look at the first column, the value is 0.8 and the other top is 0.03, so the corresponding area is 0.2033. So we get 1 minus 0.2033, so the answer is 0.7967. Okay, C. Find the number of students that obtain A if the number of students taking the test is 2,000, and to obtain a grade a student must achieve at least 75 marks. Okay, and ask that find the number of students that obtain A if a student must achieve at least 75 marks. So we write in mathematical equation. So we get Px greater than or equal to 75. We draw X distribution with mean 60, and we draw line 75, and we sketch area that greater than 75. Okay, we change to standard normal distribution. Pz greater than or equal to 75 minus 60 over 6, when we get Pz greater than 2.50. Okay, we draw z distribution. We get 0 as a mean, and this area Pz greater than 2.50, and from statistic table 2.5 in first column and 0.00 in the top, and the corresponding area is 0.00621. We can write 0.00621 as a answer, but the question asks find the number of the student that obtain A. So the number of student obtain A, the area 0.00621 times with 2000, and we get 12.42. So the answer is 12 students obtain A.
For D, if 90% of the students pass the test, find the passing mark. Our normal distribution is at 60 and 36. First, let's passing mark is K. So for the student pass the test, the score must be greater than K. For 90%, that means equals to 0.9. First, we standardize the value. So K minus 60 over 6, okay, equals to 0.9. K minus 60 over 6 is on the left side because it is greater than 0.5, more than half. Okay, this area is 0.9. So to find the value, we have to find this value. How we can get the value? By using 1 minus Pz less than K minus 60 over 6 equals to 0.9. We can simplify. So Pz less than K minus 60 over 6 is equals to 0.1. So this area is equals to 0.1. We can refer to table 4. For 0.1, the z-score is 1.2816. So Pz will be z less than. We write negative in the front because K minus 60 over 6 is on the left side of 0. Negative 1.2816 equals to 0.1. We compare K minus 60 over 6 with negative 1.2816. So we will get K equals to 52.3104. Then we can conclude that the passing mark is 52 marks.
A certain type of cabbage has a mass. Okay. Okay, we let X be the mass of a cabbage with mean 1.2 kg and standard deviation 0.2. So we can write X has a normal distribution, mean 1.2 and standard deviation 0.2. Okay, how many will have mass greater than 0.9 kg? So we can write Px greater than 0.9. We draw the graph of Px greater than 0.9 with mean 1.2, and we draw line 0.9. The area is greater than 0.9. We must change x to z, become Pz greater than 0.9 minus 1.2 over 0.2. We get Pz greater than negative 1.50. Okay, we transfer to z distribution with mean 0 and 0.9 become negative 1.50. From the graph we can see that negative 0.5 in the left side become 1.5 in the right side. So we can write 1 minus Pz greater than 1.5. So we read 1.50 from table. We look at 1.5 in first column and 0.00 in the top row. So the corresponding value is 0.0668. So the answer is 1 minus 0.0668. So the answer is 0.9332. Okay, but the question asks calculate an estimate of how many will have mass greater than 0.9. So 0.9332 we times with 1000. So the answer is 933 cabbage will have mass greater than 0.9 kg.
For B, a farmer rejects 5% of a large quantity of cabbage because they are underweight. Calculate the minimum acceptable weight of cabbage. Our normal distribution is 1.2 and 0.2 square. Let the minimum acceptable weight of cabbage is K. Because we want to find the minimum acceptable weight, the probability is for X less than equals to K. It is equals to 5% or 0.05. First, we standardize. K minus 1.2 over 0.2 is equals to 0.05. Let's look for the bear shape. 0 is in the middle. K minus 1.2 over 0.2 is on the left side. This area represents 0.05. Now we can refer to table 4. For 0.05, the z-score is 1.6449. We can write Pz less than equals to negative 1.6449. This equals to 0.04. We have negative in front of the value because K minus 1.2 over 0.2 is on the left side of 0. Now we can proceed to find K. So K minus 1.2 over 0.2 equals to negative 1.6449. K will be 0.87102. We can write the conclusion. Minimum acceptable weight of a cabbage is 0.87 kilogram. Don't forget to write down the units. Okay, kilogram.
Okay, from this question, okay, X be the thickness of a component with mean 0.5 and standard deviation of 0.1. Okay, component reject when the thickness is outside the range of 0.38 cm to 0.41 cm. From this question, we can write that Px less than 0.38 plus Px greater than 0.41. Okay, look at the graph. Okay, we draw x distribution with mean 0.4 and we draw 0.38 and 0.41 and sketch the area less than 0.38 and area greater than 0.41. We change to p exact less than 0.38 minus 0.4 over 0.01 plus pz greater than 0.41 minus 0.4 over 0.01. Then we get pz less than negative 2 and pz greater than 1. Okay, if we change to z distribution, 0.38 become negative 2, 0.41 become 1, and pz less than negative 2 become pz greater than 2 and pz greater than 1, and read from table we get 2 is 0.0228 plus 1 is 0.1587 and the answer is 0.1815. So the percentage of the component are rejected is 18.15%. Another question, show that the percentage rejected will be reduced if the mean is changed to 0.395. Okay, we write X has normal distribution 0.395 with variance 0.01 squared, and the question is still the same. Px less than 0.38 plus Px greater than 0.41. Okay, we look at the graph and we change to z distribution and we get pz less than negative 1.5 plus pz greater than 1.5, and look at the graph, we can see that answer is 1.5 and 1.5. We can write as 2pz greater than 1.5 and look at the statistic table and read at 1.5, we get 2 times 0.0668 and the answer is 0.1336. Okay, from the answer we can see that 13.36% component are rejected compared to 18.15%. So we show that the percentage rejected will be reduced when mean is changed to 0.395 cm.
The weight of a chicken sold at a market is normally distributed with a mean of 1.4 kilogram and a standard deviation of 300 gram. First, we want to determine the probability that the weight of a chicken is between 1.2 kilogram and 1.8 kilogram. Let X be the weight of a chicken sold at a market. The normal distribution. Okay, we need to find the mean and variance. So in the question, it gives us mean is 1.4 kilogram and standard deviation is 300 gram. We have to make sure that both with the same unit. So mean is 1.4 kilogram. So standard deviation we change to 0.3 kilogram. So variance will be 0.3 square. Okay, now we write in form of distribution. So x is normally distributed at 1.4 and 0.3 square. We want to find probability for x between 1.2 and 1.8 kilogram. First, we standardize 1.2 minus 1.4 over 0.3. Okay, this is for z. Then 1.8 minus 1.4 over 0.3. The probability will be between negative 0.67 and 1.33. In the bear-shaped curve, negative 0.67 is on the left and 1.33 on the right. So this is the area. We can find the area or the value of probability by using 1 minus pz greater than 0.67, then minus with pz greater than 1.33. Okay, read from the table. 0.67, we will get 0.2514, and for 1.33, 0.0918. 1 minus 0.2514 minus 0.0918. The value will be 0.6568. For B, the chicken is considered small if it weighs less than 1 kilogram. Determine the percentage of chicken that are small. X is the weight of chicken sold at the market, and normal distribution is at 1.4 and 0.3 square. So we want to find, okay, when the weight is less than 1 kilogram. Px less than 1. First we standardize. Okay, change to z. Z less than 1 minus 1.4 divided by 0.3. It will be z less negative 1.33. So from the graph, negative 1.33 is on the left side. So we can find the value or the area under the curve when we use pz greater than 1.33. Okay, read from the table. The value will be 0.0918. But remember, the question want the percentage of chicken that are small. Write the conclusion. Therefore, 9.18% of chicken are small. That's all for lecture 3. We will continue on lecture 4 or 4.